Question 1. Estimate the number of hours sleep a typical person in Scotland has during their lifetime. So this is a Fermi estimate. So I need to assume how many hours sleep. So I write assume. Let's just go for the standard 8 hours per night or day. And we're going to need to assume how long we live. So assume we live 75 years, seems reasonable. And we're going to also assume 365 days a year, just to avoid the leap years. So then we just do 8 times 75 times 365, 219,000. 219,000 hours. Just look at them asking for question 1. Since it's a Fermi estimate, you've got a bit of leeway. 6 to 10 hours a night, as you could have used anywhere between 65 and 90 years for the number of, anywhere between 65 and 90 for how long you live. You have to use 365 days or a suitable number of weeks, and then your times. Obviously, I've done the same as the SQA, 8 times 365 times 75, but you might have a different answer depending on the number of hours, years you used. Just make sure it wasn't outward for that range. And we're done there. Clelland Maths is sponsored by Lecky, the educational publisher for Scotland. They offer viewers of this channel a massive 30% discount. Just use the discount code ClellandMaths at leckyscotland.co.uk. The practice question books go all the way from level 3 to advanced higher and include National 3, 4 and 5 apps as well, so you can get any book you need for your studies. These are an excellent resource with questions on every topic and contain work solutions so you can see how the marks are awarded. As you go through the book, the questions get increasingly difficult, so by the time you finish your book, you'll be ready for your exams. Usually £9.99, just use the discount code ClellandMaths to get 30% off that. Link down below. We have applications of maths specimen paper from August 2023. Question 2. A group of students were asked the different types of TV shows they regularly watch. I have a comedy, reality and drama, and we've got all this information, and we have to complete a Venn diagram. So to complete a Venn diagram, you always start from the middle and work your way out. So we want all 3 in here. So 8 watched all 3. So I can put 8 in, take a little tick. And then for both, so for both drama and comedy is 14. So that is the intersection here. So I need to do 14 take away 8, which is 6. Use a calculator anytime you want. 12 watch reality and drama, so it's 12 take away 8, which is 4. And 45 watch comedy and reality, so it's 45 take away 8, which is 37. So we get them, and then we go for our singles, and this is where a calculator is probably useful. So for comedy, I've got 60, and I take away all the ones in the comedy circle, which is 37, 8 and 6. That gives me 9 for comedy. For reality, 55, watch reality, so it's 55 minus 37 minus 8 and 6. 8 and 4, which gives me 6 for reality, and drama 21, so minus 6 minus 8 minus 4 in that circle gives me 3, and then don't forget the one outside, 2. So 2 hanging about outside. And we're done there. Part B, if a student is selected randomly, find the probability they watch reality and drama TV programs, but not comedy. So we've only watched reality and drama, so that's 4 students. So it's 4 out of the total. So how do I find my total? I just add up all the numbers in my Venn diagram. 2 plus 9 plus 6 plus 3 plus 4 plus 6 plus 37 plus 8 is 75. So 4 out of 75, or if you prefer a decimal, 4 divided by 75, 0.0533, but this answer is probably better, simplified fractions. And we're done there. SQA Higher Application of Maths Specimen paper from August 2023. Zach deposits £500 in the bank on the 1st of January 18, 1920, and it pays Visa effective interest rates per year. It makes no other withdrawals, calculated balance at the end of 2020. So a little timeline can help with this. We've got the 1st of Jan 2018. He puts 500 in. Then we go to the 1st of Jan 2019 and he puts 500 in. And he goes to the 1st of Jan 2020 and he puts 500 in. And with the calculated balance at the end of 2020, so that is 21 basically. So we've got 1.033, we've got 1.024, we've got 1.01, and then we've got nothing going there. So we start off with 500 times 1.033 plus the 500. That gives me 101650. So we go 101650 times 1.024 plus the 500. That gives me 1540,896, so 1540,90. So then we go 1540,90 times 1.01, but we don't add another 500. To get 1556.31, 30931. 1556.31. In January 2021, Zach deposits another £500 into his account. He makes no further deposits. Calculate the annual effective interest rate needed in 2021 for the account to be 2100 by the end of the year. So I need to do 2100 divided by how much is in his account. So 1556.31 plus 500 is £2,056.31, and this will give us the interest, but it'll be 1 point something. So let's have a look. 2100, 2056.31. That gives me 1.021, 1.0212. So then we need to take away 1 and times 100 to get it as a percent. So just keep it in the calculator, take away 1 times 100, 2.124%. So I'll just put dash, 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 2.12%, and we're done there.
SQA, High Applications of Maths, Specimen Paper 1, Question 4. You must refer to spreadsheet school rule when answering this question. Complete parts A, I, and CI using the spreadsheet file, and complete parts AII, B, and CII in the space below. So it says, a school is planning a new building as it is approaching maximum capacity. The school rule in August of 2021 was 650. Approximately 18% leave at the end of each year and 150 new join. Complete the school rule worksheet to predict the school rule in August 2031. So this is what you call a recurrence relationship. And let's go straight away into the worksheet and see what happens. So here we are in the worksheet, and we've got number of pupils, 650. It tells us the leavers is 18%. So the first thing we need to work out is this box here, school rule at the end of year percent. Well, if 18% leave, that leaves me with 100 minus 18 left, 82. So 82%. Happy with that. And then we have to work out the school rule in 2031. So I'm going to have to go into here and start using a formula. So let's have a look at the formula. So this is pupils we're talking about. So we can, since it's all approximate, we can just say round and let it round up, or press int and then let it just truncate it. I'll do round. If it was exact, I would use int, to be honest. Round, and then we're going to say, well, we want the pupils times 82%, but we want that as dollars, which you can just press F4 once I've clicked it, or type it in. 82% of that plus, well, we add on an extra 140, and again, we want the dollars because that's outside the table. So the only one you want not dollar is the C14, comma 0, because we want no decimal places. And we'll get an answer. Now we can just copy that down. We can either just drag it from the corner, and we get 761. So let's go back to our question. Complete the school rule to predict. We've done that. It was 761. Let's just take a note of that. Comment on the precision of this prediction. Well, how precise is it? Not particularly, because it's approximately 18% leave, and it says 140 new pupils join. Well, how precise is that? Is it exactly 140? Could it be 31, 131, something like that? The number of pupils leaving each year is only approximate. And that'll be fine. Okay, comment on the relationship between time and the predicted school roll up to 2031. So let's go back to that spreadsheet to see what's happening there. If you look at the spreadsheet, you can see that the numbers just increase up to 2031. So that's all it's asking us to do, is to write as time increases, school roll increases each year. The school moves forward with plans for a new building. This will increase the capacity of the school to 800 pupils. Extend the table in your worksheet to construct a graph to predict what is going to happen. You must consider what happens beyond 2031. Use your graph to determine whether the new capacity is suitable, which is 800 pupils. So let's go back to that spreadsheet and see what's going on here. So there is our spreadsheet. We want to extend this table. So let's just start copying this down and see what happens. Well, it looks like it's still increasing. If I were you, I would keep going till it starts to look like something's happening, you see? So you can see it's slowing down. Up, there we are. You see how it's suddenly 776? Doesn't matter how far I go now, it's going to stop at 776. So that's what we're looking for. Now we want a graph for that, so we're going to... So you got the insert. Recommend charts is always a good one, but just watch the axes here. This one I'm not going to pick because it's not determining the same as this. So I'm going to pick maybe that line one or maybe that one. It doesn't really matter what one you pick. This one's appropriate. Usually a line one or a dotty one, scatter graph basically, would be good. I'll just move that up a little bit. Now, always want your axis titles. So you click it and click axis titles. We want this to be school roll. And then this will just be year. And will be a number of pupils against year. So just making sure I've got an appropriate label so that I don't lose any marks for labeling. But notice what's happening. It grows and then it levels off. And we can see that from the table anyway. It levels off at 776. So let's go back to answering the question in our page then. Use your graph to determine whether new capacity is suitable. Yes. As school roll never exceeds 776 pupils. Or it levels off at 776. And we're done there. SQL applications and maths. Specimen paper 1, question 5. The activity network for a garden renovation project shown below. Explain using examples from the project the difference between an activity that is essential for the project and critical for the project. So we're looking for critical and essential projects. So remember, critical means there is no float time. So there's quite a few you could choose from in this question, but let's have a look to see what ones. So if you look at A, for instance, that's not critical, so that would be essential. B would be critical because it starts at 0, takes 3, and lasts for 3. C would be critical, starts at 3, lasts 4, ends at 7. 3 and 4 make 7. So any time when these two numbers add up to the end number, that would be critical, okay? So let's pick one of these critical tasks. I'll just pick critical. I'll just say C, and then we need an explanation for that. So what we're looking for here is any delays to that activity would cause a delay in the whole project's end date, okay? So it's on the critical path. And you could say something like, any delays would delay whole project. And then let's look at essential tasks. So essential is any other task. Essentially, it has to be done, but there's some flexibility in the time. So if we look at, say, A, for instance, with A, it starts at time 0, first day in other words. It should take 2 days, but it can end on day 3. It doesn't end on day 3, but it can end on day 3. So you can say an extension is needed for the project to be finished, but there is flexibility in the time. Needs to be completed, but I'll just zoom in here, flexibility in time. And we're done there. Describe the meaning of each of the three values in activity C's node. So the node is just these three numbers here. So looking at activity C, we've got 3, 4, and 7. So what does that mean? Well, is this about days? Probably. Let's just assume it's days. 3 means activity starts at the end of day 3. So it cannot start to end of day 3. What does the 4 mean? Well, the 4 means that the activity is going to last 4 days. And then the 7. So the 7 is the latest possible finish time for the activity to be completed. Latest completion time. And we can just write what that actually means, the end of day 7. And we're done there. Part C. Produce a Gantt chart for the above project. You do not need to include float times. I'll explain what happens if you had to include float times, but let's just do that now. So we can go down the way or up the way, but I'm just going to go down the way. So we're going to start with A, space B, space C, then D, then E, then F, then G, and then hopefully there's a H as well. There is. There was no H. I can delete that one then. So A, B, C, D, E, F, G. I feel like yeah, A, B, C, D, E, F, G. Okay, so we can call that label activity. Always need a label. And then we want our day at the bottom, so we'll just call that day. And we're going to go for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and so on. So now let's look at our actual thing. So for A, it starts at the end of day 0, and I was on day 1, and it lasts 2 days, so 2 boxes. So I can just draw 2 and shade in 2. Now, also, you use a ruler to be nice and neat. B also starts at the same time, it takes 3. So there we go. Just shade that in. Now, talking about not including the float time. So if you look at A again, it goes 0, 2, then it says 3. So 3 is like one more box. So if I wanted to include the float time, I would draw another box and maybe just not shade it in and have a little key at the side to say that box means float. But we don't need it for this task. So let's move on to C. C says starts at 3, lasts 4. So after that one is 3. 1, 2, 3, 4. Again, using a ruler when you're actually doing this, but there you are. And then D starts at 7, takes 3. So where is it? That one there. And then E also starts at 7 and takes 2. So just 2 boxes. And then we've got F starts at 10 and takes 2. So 10 will be here after 10. Start at 10 really, it starts after day 10. And then G starts 9 and 1. So just need to go back 9 and 1. And there's our completed Gantt chart. So we're done there.
It's great higher application of maths, 2023 spec paper, August. Question 6. The 3 diagrams below show a parachute's height varies above the ground over a period of time. So you've got A, B, and C. Which graph can't mod over jump? So if you jump out of a plane, you're always going down. You never jump back up. It might look like it does in the movies because it's getting filmed by someone falling, but actually you always just go down. So that goes down all the time. That goes down all the time. This one goes down and then seems to jump up. So it's B. B. Height cannot increase during parachute jump. And we're done there.
SQA Higher Applications of Maths, Specimen Paper 1, Question 7. The average price of petrol increased at the following annual effective rates: 3.1, 0.5, 2.0. We have to calculate the overall percentage increase from March 2018 to March 2021. Well, we can't just add these together and divide by 3. It doesn't work like that. This is accumulation. So really I'm doing, if I was to take a value and times up for 3 years, I would do 1.021 times 0.5% becomes 1.005 times 2% would be 1.02. I'll take a value and times by that. So if I do that, that will give me my overall percentage increase, but with a 1 on the end and a decimal. So I'll do that first. So I've got 1.021 times 1.005 times 1.02 is like 1.0466. So then I need to take away 1 to get it back to a decimal. Take away 1 and then times 100 to get it back to a percent. So use my calculator, take away 1, press equals, times 100, press equals again, and I've got 4.66%. And we're done there. So now, part B says, the average price of petrol in March 21 was 136.4 pence per litre. Calculate the average cost of filling a 40 litre tank in March 2018. So I'm going back in time. I'm not going forward. If I was going forward, I would do 136.4 times that times that times that. Or, because I've just done the work to work out what that is overall, just times this, because that's what that is. Since I'm going back in time, I can just divide by that. So that's the method. Going back, going to an original price, a present value, you're dividing. So 136.4 divided by 1.0466. That'll tell me the price per litre. 136.4 divided by 1.0466 is 130.326. So it's only been quoted in 1 decimal place, so I'll do the same. 130.3 pence per litre. And now I want 45 litre tank, so 45 times 130.3. Well, that's 5863.5, but you would never be quoted it like that because that's now in pence. So if I divide that by 100, I'll get it back to pounds. So dividing that by 100, that gives me 58.635, so 58.64, because you're going to get it rounded up. £58.64. And we're done there. If we have a case of the maths specimen paper 1, question 8, you must convert the spreadsheet file Q8 biomass data when answering this question. Complete the parts in the software. Okay, so let's read this question. The UK has a mix of renewable technologies and fuels, including biomass, which is a key fuel source for decarbonation of electricity generation and heat provision. Wood chips are an example of a source of biomass. The heat power of wood chips is used to generate energy varies depending on the moisture content. The data in the spreadsheet file shows moisture content percent and associated heat outputs, kilowatts, of various samples of wood chip. Construct a scatter diagram and make 2 comments. So if we construct a scatter diagram, this is an RStudio question. So let's jump into RStudio now. And there we are, I've already got it loaded up. So we need to go to File, New File, RScript, and then Session, and set Working Directory, and we choose Directory. So I need to find my directory. I know it's on my desktop somewhere, so I'll do that now. So you should be able to see here that my files are now in there. So I need to then start what I usually do, which is my data. So for my data booklet, my data, /- read.csv, put that in brackets when I shouldn't have done, read.csv, and inverted commas, Q8 and biomass data.csv. Make sure you're getting all the spaces and capitals that you need. Control Enter. If it works, you've loaded it. And then we need to attach my data. So the usual. And now we wanted a scatter plot. So if you can't remember, check the data booklet. It's under graphics usually, and it's under plot. So we have got plot x, y. Now we need to know what x and y are. So check your data, moisture and heat. Now, the heat is based on the moisture content. So the moisture is the x. So I'm going to write moisture. It should come up once I've started typing it, comma heat. And then it's x lab equals and y lab equals for your axis labels. So x lab equals moisture content. And it was in percentage, so I'll do that. Comma y lab equals heat output. And I think it says, I'm looking at the question now, kilowatts. So I'll just put bracket kilowatts. KW. That'll do. And then you've got the usual main equals scatter plot of y on x. Scatter plot of heat output on moisture content. PCH equals 21, BG equals black. That just is commands really for the formatting of it. And that should produce my scatter plot if I'm crossing my fingers and not done anything wrong. So I'll make 2 comments about the scattered graph. So let's just quickly remind ourselves what a scattered graph looks like. It looks linear because it's sloping down the way. You could put a line of best fit on that if you're not sure. So a linear relationship between moisture content and heat output, but it's also a negative relationship or a strong negative relationship because it's going down the way. So that's what I'm going to write, something like that. So linear relationship between moisture content and heat output. I'm going to put a strong negative association or correlation between heat, moisture content and heat output. I think that'll be enough to get you 2 marks. I think if you mention it was a linear ratio, you get a mark. If you mention it's a negative association or a strong negative association, you'll get a mark there too. Find the equation of a regression line of heat output on percentage moisture content and then estimate something for 35%. So we need to go back to our RStudio here to do this. So back to RStudio, it wants us to find the equation of the regression line. So if you go to your data booklet, what you're looking for here is under correlation. Now, LM, Y to the X, just puts the line on. AB line is the one you're looking for. AB line just puts the line on but doesn't tell you anything about it. LM is the one you're looking for. I'm going to put both on just to show you. So if I put the AB line on first, just to kind of show you what the line looks like on this. So I've just copied this. I'll put Y, remember Y was heat, and X was moisture. That just gives you the line, doesn't tell you anything about it. So if I want an equation of that line, I need just LM, and then heat, and then moisture. And what that does, it gives us an output. Now, what is this output? Well, we've got 2 things. Coefficients, intercept 7.95, moisture, it says minus 0.05. If you remember from National 5, the equation of a straight line's y equals mx plus c. C is where it's the intercept, so that's the second number. And the moisture, the first one, is your gradient, that's your m. So that's what we're going to write. So if you go back to your thing, I'll just take a note of these numbers for us. So the output I got was, it says intercept 7.95778, and it then said moisture, but it actually means the gradient for that part, minus 0.05751. So our equation is the y-axis, which is heat output, equals, now I always remember the other way around for higher apps, I write the first number first, so 7.95778 is what I'm going to write first, because that's the one it gives me. I'll just round that to 7.96. Now not plus anymore, because the second number is negative, so 7.96 minus 0.05706 would be fine, times mx times moisture content. Or you can write it the other way around if you prefer. 0.06 times moisture content minus 0.06 times moisture content plus 7.96. But I prefer to write it in the order I'm given the output because it's easier to remember. And now it says estimate the heat output of wood chips of a moisture content 35% and interpret this estimate referring to a prediction interval. So again, this is an RStudio thing we're looking for here. You could put it in to this equation, but you're not going to get the prediction interval. So let's do it in RStudio. Okay, so you've got predict LM heat tidal moisture, new data equals data.flame, moisture equals 35, but what 35%, interval equals pred. If you do that, you get three values: fit, lower, and upper. So we've got three values here. 5.9 is the fit. That means that's the actual value for this sample of things. But we've got a LWR and a UPR, the lower and upper. That is for the true, all wood chips. So the true heat output for all wood chips at 35% moisture content is between 5.26 or 5.3 and 6.6. So that's all I need to write in my Word document. The heat output is 5.9 kilowatts, but the true heat output is likely to be between, and the two numbers are 5.3 and 6.6. Oh, well done there. Part D, explain the implication of the analysis for anyone intending to use wood chips as a source of heat. So remember, if we look back at our RStudio, the graph was sloping down the way. That means that as the moisture content gets bigger, the heat output gets lower. So you want to have a lower moisture content for a higher heat output. So that's all we need to say. The lower the moisture content of wood chips, the higher the heat output. Oh, well done there. SBI Applications of Maths, Specimen Paper 1, Question 9. A TV production company is responsible for the delivery of a new quiz show to national television. If the production is delayed, the company is charged an additional £10,000. For the purpose of a cost-benefit analysis, it is assumed that there are two events that could cause a delay. 0.3 if a key member of staff falls ill, 0.1 for equipment failure. Now this question is saying calculate the expected value of cost should be considered for the cost-benefit analysis. It's been a bit wishy-washy here. Usually you just get told what's going to happen if one or more things fail, but let's do it based on that. So we want, what's the probability of nothing happening? Now I always do this with a tree instead of having to overthink it. So I always start off by saying, look, I'm here. And if somebody falls ill, I could say, well, ill, not ill. 0.3 if you fall ill, and then it adds up to 1, so it must be 0.7 for not being ill. And then going away again, I could have equipment failure, so failure, no fail, I'll put. And equipment failure 0.1, which adding up to 1 again gives you 0.9 here. And you'll have the same that way. So failure, no fail, 0.1, 0.9. Now, if I wanted to know then, what's the chances of something not happening, I could work out all the things that could happen, or just go for the option where it's fine. So the chances of nothing happening are 0.7 times 0.9. So the probability of no issue is 0.7 times 0.9, which using a calculator is 0.63. So that means that the probability of at least one thing happening, either being ill or equipment failure or both, is just 1 minus that answer because it has to add up to 1. You're either going to have no issue or you're going to have an issue. So the probability of an issue, at least 1, is 1 minus 0.63. And you can use a calculator to work that out to get 0.37. So then we can calculate the expected penalty for at least one issue. £0.37, and it says it was going to be £10,000. So times that by 10,000. Which is £3,700. So that's my cost-benefit analysis. I've worked out what happens if something bad happens. I'll get the chances are that I'll get charged in the long run £3,700. If I did it over and over again, 0.37 times, 37% of the time, something would happen. Okay, moving on to part B. It is possible to use the following control measures. Control measure 1, employ backup staff to replace someone who's ill, and that costs £1,000. Control measure 2, spend £3,000 on an equipment inspection to ensure all equipment is functioning. Calculate the expected cost if control measure 1 is taken. Well, if control measure 1 is taken, I'm automatically getting charged £1,000. Simple as that. But that means that somebody could still, no one can be ill now. Well, we're going to replace them. But equipment failure could still happen because I'm not putting any measure in place. So what's the chances of equipment failure? Well, up here it says 0.1. So I need to then add 0.1 times the expected penalty, which was £10,000. So there's my sum. So that's 1,000 plus 1,000. That's just 2,000. You can use your calculator for that. Part C, the expected value of cost of control measure 2 is taken is 6,000. They're just telling us, they're not asking us to work it out. State which control measure should you take? Well, we know that if you do nothing up here, it's expected to cost you £3,700. But if you take control measure 1, it's going to expect in the long run to be 2,000, and control measure 2 is 6,000. So it's obviously the cheapest one, isn't it? So control measure 1. And we need to support our recommendation because it is the lowest expected cost, not the lowest cost. If something happens, you're paying £10,000, but the lowest expected in the long run. Lowest expected cost. And we're done there. SQA Applications and Maths Specimen Paper 1, question 10. Let's have a look at the first question. This is Excel 1. You must have hit a spreadsheet, but Carol receives a gift of £2,500 and is considering what to do with it. She has a savings account that pays interest at an annual effective rate of 1.25%. Calculate how much interest Carol would earn if she invested this gift in her savings account for 34 months. So this is the first part of the question, which is not actually the Excel part. So we've just to work this out ourselves. So I need to do 2,500 times 1.0125. But then it's 34 months. So it's 34 months out of 12 months. So to the power of 34 out of 12, which is 258,956. But I need to read the question. It says how much interest. So I need to take away the original amount you had, which is 2,500, which will give you £89.56. Hopefully that's quite easy. And we can move straight on to the actual Excel part. So here's the Excel part. She has a personal loan. She borrowed £8,000 to be paid by level monthly payments for 48 months. The first repayment made 1 month after the loan. Interest is charged at 4.9%. Open the loan schedule, original loan, and complete the formula in the loan schedule to calculate the level monthly repayment amount and the final repayment amount. So this is your standard thing. So let's do part B. So first thing we need to do is the monthly effective interest rate. So that equals brackets 1 plus the percentage for annual to the power of 1 over 12. And then you need to take away 1. And you get 0.4%. So monthly repayment, well, we have to work that out. We don't know, so we're just going to guess it. So I'm just going to say 200 and have at it. And then we go into our table and try and work out our table. So month 0, nothing happens. This is usually filled out for you. And the loan outstanding was, again, it's usually filled out for you, but it's not for this question for some reason. So we'll just go and check it out on the question. £8,000. So that's what should be in here. And then we can start at month 1 and month 2. So repayment, well, that equals our guess, and we dollar that, so F4. Interest content of repayment next. So that equals our monthly interest, dollared. But let's actually round first, remember. Round our monthly interest dollared times the loan outstanding, which is not dollared, and then it's comma 2 because I want 2 decimal places. That's the one that you round. So there's our interest content repayment. Capital is repayment minus interest. And loan outstanding is loan outstanding minus capital. So that's us done month 1. We can copy that down for month 2. And then we can just keep copying down for all the months we need. So how many months is it? Well, it's 4 years. So that's 4 times 12, which is 48 months. So down we go. And my guess has taken into the negatives, so it's too much. So we need to go seek it to see what happens. So press that, and you go to data, what if analysis, go seek. Set cell there to value 0 by changing cell. And it's going to be the one we guessed at the start, the monthly repayment. Let it run and do its thing. Eventually it'll get an answer, 183.49 it says, but remember that answer isn't actually 183.49. We have rounded that for you, so you need to adjust yourself. So the next step is 183.486. You can round it up if you want to 49, or you can leave it as 48. It's up to you. I'm going to round it up to 49. And then I need to adjust my final repayment manually. So going down the bottom, you can see here that it says minus 0.21. So I need to take this and go minus 0.21. And then I'll go 0 or dash. And that's me done there. So the final repayment is 183.28. I'll just write that in there. Final repayment, £183.28. Anyway, let's go back to the question and see what it was asking us. We have a monthly repayment and final repayment amount. So I've done that. We got £183.28 for the final and 183.49 for the level monthly repayment. Next part of the question. Carol has just made her 14th repayment on the loan. She decides to find out the impact of using £2,500 gift as a lump sum to reduce the outstanding balance. The loan provider agrees to reallocate the new level monthly repayment amount to be paid over the remaining 34 months. Copy the loan worksheet and rename it Pay Lump Sum. Adjust it as required to calculate the new level monthly repayment. On the Pay Lump Sum worksheet, calculate how much Carol would save in interest payments by making this lump sum payment. And then state a reason for something which we'll get back to in a minute. So let's go ahead and look at our Excel. So let's copy this over. We're going to make a copy, it says. So this is called Pay Lump Sum. Now it's after the 14th payment. So I'm going to add 2,500 in this point. So now I'm going to have to goal seek this. So I'm going to have to do a new monthly repayment for all of that. So let's take a new tab, call it new repayment. And we need to reference it from this point. So let's just goal seek this. So let's call it 200 for the sake of it. Let's make it money. So we're going to goal seek this one. And we'll just copy that down from there. You can just double click there if you want. And let's goal seek. What if analysis? Goal seek. We still want that to be 0 by changing our new repayment. So it does some work and we get £105 exactly. It's not 105, is it? It's rounded at 104.70, but 71 is what the SQA wanted, so we'll put 71 in. Format cells. Currency to 2 decimal places. And then final repayment. We're going to have to adjust our last one again. This should all be currency, so it's not been set up for us, so we just need to do it ourselves. Format cell. We'll just say currency 2 decimal places. If that happens, it happens. I mean, this is an old paper, so chances that won't happen. Final repayment, so take away the 0.27, and we get 104.44. And there we are. So now we need to work out the total interest for both of these. So for interest for this one is equal to the sum of all the interest payments. £628.73. And then on the original one, we want the sum of all the interest payments. Which is £807.31. So our difference is, so it was £807.31 minus £628.73, £178.58 is the amount saved. In terms of the last question, state one reason why Carol may choose to pay the gift into her savings account rather than use it to reduce the balance of her thing. Well, it could be any reason. She might just want to save the money, have the money accessible. So just to write something to ensure that her money remains accessible would be a reasonable thing, and we're done there. SQA, higher up case math spec specimen paper 1, question 11. You must refer to the information Mountain Girls on the pre-release material. And it says, in 2020, study found the population of mountain gorillas had increased to 1,004. An expert stated that if mountain gorilla population in Virginia continues to grow exponentially, there will be 1,600 gorillas by the year 2032. Is he correct? I'm not sure if this question is actually very fair, but we'll do it anyway. Let's look at the data. Looking at the third paragraph, it says, a study in 2008 showed that there were 680. And a further study in 2020 had increased, and we know how much it's increased by because it tells us in the question. So from 2008, it was 680 is the main key part. So if we go back up to our question, 2008 was equal to 680, and then we know that in 2020, it was equal to 1,004. Well, there's a 12-year gap there. Events want us to look at 2032. The key thing is, if it's exponential growth, if it's say doubled that time, it doubles in the same time period. That's how exponential growth works. So if I work out what fraction this has went up by, I can work out what I expect it to be by timesing them by 1,004, and that is the kind of answer. So in 2032, I would expect it to be 1,004 over 680, because that's what fractions went up by, times 1,004 again. So I'm expecting it to be 1482 roughly. So expect 1482. So he said 1600, therefore wrong, because 1482 is less than 1600. He's thinking there's going to be more than that. Part B a bit easier, so if you didn't find that one very easy, Part B, a typical adult mountain gorilla eats 30 kilograms of food per day. This is going to be a Fermi estimate. Estimate the maximum amount of termites and ants in kilograms that a typical mountain gorilla will eat during their adult lifetime. State any assumptions you made. Okay, so let's have a look at the data to see what do we know about adult mountain gorillas? How long do they last, live, whatever? How much do they eat? So, I know from reading this before, I can go blah, 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 way down to this paragraph here. Mountain gorillas are considered adults when they're 10 years old and live an average of 35 years. So that means that if we're adults at 10, live to 35, we can assume that we'll live about 25 years as an adult. So let's start with that. Assume 25 years as adult. What else can we do? We survive mainly on a vegetarian diet, but we do eat some ants and termites. But the diet remains vegetarian, mostly, right? So mainly vegetarian. What does that mean? Well, if you think about a percent here, if I'm a mainly vegetarian person, I can't eat more than 50% meat. In fact, if I ate 50%, I'd be 50-50. I wouldn't be mainly vegetarian. So it means I have to eat at least 51%. So we're going to assume as a maximum, because it wants a maximum, 49% ants and termites, because that's the max that they can possibly eat. Otherwise, we're no longer vegetarians, mainly anyway. Okay, so there's two assumptions. If you can get that 49%, you're pretty much done. So then we're going to say the last thing we always assume for a year, 365 days per year, just to avoid the leap years. And then we just times. So 30 kilograms a day. So starting with 30, we're times it by 365 days in 1 year, we're times it by 25 years, and then 49%, 0.49. And that gives you 134,137.5. I think we would probably round that to about 134,000 kilograms, but I think you'll get the answer for anything between 130,000 and 140,000, but I'll round it to there and be happy with that. And we're done there.